In today's lesson, I will show you how to solve inequalities. The emphasis will be on quadratic inequalities. In other words, inequalities that have the highest exponent 2. The methods that I teach will work for all inequalities. X squared subtract 3x less than 4 is an inequality. The less than symbol makes the sentence an inequality. It's read x squared subtract 3x is less than 4. To solve the inequality means to find all values of x, where x is a real number, that make the statement true. So to solve this, we need to find all values of x that make x squared subtract 3x less than 4 a true statement. By inspection, one can see that 0, 1, and 2 are solutions. So by inspection, we can see that 0, 1, and 2 are solutions. I'll show you what I mean by looking at these. So we have x squared minus 3x less than 4. Well, if I replace x by 0, first of all, just put in the parentheses. And let's check 0. Well, 0 squared is 0. 3 times 0 is 0. 0 minus 0 is 0. So 0 less than 4 is true. 1 also makes it true. Replace the x with parentheses. And put 1 in the place of x. That's going to be 1 squared is 1. Minus 3 is less than 4. Negative 2 is less than 4, which is true. Well, in our heads we can see that 2 also makes it true. 2 squared is 4. Minus 3 times 2 is 6. 4 subtract 6 is negative 2. Negative 2 is less than 4. So 0, 1, and 2 make the inequality true. So 0, 1, and 2 are solutions. Negative 2, 5, and 10 are not solutions. Negative 2, 5, and 10 will not make the inequality true. Let's just look at negative 2. Again, replace the x with the parentheses, copy everything else the same, and then we're going to substitute in negative 2. Negative 2 squared would be 4. Subtract 3 times a negative 2 is less than 4. Be 4 subtract a negative 6 is less than 4, because we multiply before we subtract, which gives me 4 plus 6 is less than 4. 10 less than 4, which is false. So negative 2 makes the inequality false. Therefore, negative 2 is not a solution. 5 is not going to be a solution. Let's do that in our head. 5 squared is 25. 25 subtract 3 times 5 is 15. So 25 subtract 15 would be 10. 10 less than 4 is false. Try 10. 10 squared is 100. Minus 3 times 10 is 30. 100 minus 30 is 70. 70 less than 4 is false. So negative 2, 5, and 10 make the inequality false. So negative 2, 5, and 10 are not solutions. One may be able to determine integer solutions by inspection. In other words, we were able to find 0, 1, and 2. And I guess if we looked long enough, we could probably find all integers that made the inequality true. However, one would never find all real solutions. A strategy to find and show all real solutions is needed. I'm going to put a star on this one, which means that you need to put it on your study sheet and you need to know it. So this is one you should be able to repeat and explain at any time. To solve any inequality, step 1, determine the boundaries. The way you determine the boundaries would be to solve the related equation and note any undefined conditions. So I'm going to get boundaries from 2 places. The solution to the related equation and any undefined conditions such as division by 0 or a negative under an even radical. Step 2. Place the boundaries on the number line. As you place the boundaries on the number line, use a solid dot to indicate inclusion and an open dot to show exclusion. Now if I want to include the boundary, I use a solid dot. Now less than or equal to, greater than or equal to, tell me to include. So if you have less than or equal to, greater than or equal to, you're going to have inclusion, which means you use a solid dot. Less than or greater than, in both cases that's or rather than one symbol. So less than or greater than indicate that you do not include the dot, so you use an open dot to show exclusion. So we cannot use equals in this case. We have to exclude the boundary, because the boundary would imply equals, and we can't have equals. We have strictly less than or strictly greater than. Step 3, you choose checkpoints from each region and substitute each point into the original inequality. Now this might be hard to understand now. I'm going to work several examples step by step and I'll explain what the step means. So you need to use my examples to make sure you understand the strategy. Then you need to use the strategy to solve all of your inequalities. So step 3 says choose checkpoints from each region and substitute each point into the original inequality. And then step 4 says show the true regions, or to shade the true regions to indicate the solutions. So shade the true regions to indicate the solutions. I'm going to illustrate the strategy by using a linear inequality. That means the highest exponent is 1. So let's solve 2x minus 4 is greater than or equal to 6. So it is an inequality. Step 1, get the boundary, and there'll just be one boundary this time, by solving 2x minus 4 is equal to 6. So when I say solve the related equation, I simply mean replace the inequality symbol with equals and solve as you always do. Okay, to solve 2x minus 4 is equal to 6, I need to change the subtraction to adding the opposite. So we have 2x plus a negative 4 is equal to 6. Now I need to eliminate the negative 4. To eliminate a negative 4, I need to add a positive 4 to both sides. So notice I'm adding a positive 4 to the left member. I'm also adding a positive 4 to the right member. Now negative 4 plus 4 is 0. 2x plus 0 is 2x. 6 plus 4 is 10. So again, negative 4 plus 4 is 0. 2x plus 0 is 2x. 6 plus 4 is 10. Now, of course, I need to divide by the coefficient. So divide both sides by 2 to get x equal to 5. So x equal 5 is the boundary.